Our next speaker is Dr. Joel Kearns. He is the Deputy Associate Administrator for Exploration at NASA's Science Mission Directorate. He's going to be giving us an update on exploration science strategy that NASA has to offer. Dr. Kearns?
Thank you. It's a pleasure to be here this afternoon. I will give you an update on Science Mission Directorate's exploration science strategy and science integration, which includes, on behalf of the agency, the commercial lunar payload services activity. If you go to the next chart, please. There are several elements that take place within Science Mission Directorate at NASA headquarters, specifically for exploration science strategy and integration. The first of those are implemented under the Lunar Discovery and Exploration Program, or LDEP, and these include developing new lunar surface science instruments, particularly for scientific studies, using commercial companies to deliver payloads to the moon, which is CLIPS, developing mobility systems to improve and enhance the science investigations on the surface, leveraging international partnerships to provide some type of additional opportunities. These could be, for example, places to get to places on the moon where the US is not currently planned to go, or to have some type of new instrumentation or measurement capability or some type of service capability that we don't have today. And then obtain new scientific data from the cislunar area using small sats. And in addition to those, outside formally of LDEP, is coming up with the methods and techniques to exploit new human exploration systems such as Gateway and the human landing systems on the surface, and leading the science part of the mission planning for humans on the lunar surface. I would also add that in addition to the things we're talking about today, which are focused on cislunar space, part of the science strategy and integration is also to help NASA look forward to the science planning for the first crewed missions to the surface of Mars, and based on that science planning, provide input to what activities should take place on the moon to get ready to support that science, which will eventually take place on Mars. If you go to the next chart, please. Now, many of you are probably familiar with the activities that are planned to date for commercial lunar payload services, but just to provide a little bit of background information, there are 14 companies that have been selected by NASA in response to competitive solicitation that are part of the indefinite delivery, indefinite quantity pool that NASA then chooses from when we identify a need to have a particular delivery mission to the lunar surface. So those are listed here on the top right of this chart. And again, some of the things to emphasize is that in structuring the delivery services the way we have, NASA is not developing lunar landers. We're not running missions to the surface of the moon under CLIPS. What we're doing is we're buying a delivery service and a way to get our data that we've asked for from the equipment that we've asked the providers to take to the lunar surface for us. And what our intent is here is we want to be one of many customers for this type of service to cislunar space. We want to have a relatively frequent access to the lunar surface, and what NASA plans is to purchase roughly twice a year deliveries to the moon every year for the foreseeable future for these robotic unmanned deliveries of equipment, instruments, and technology. And as of this date, we've got 6 awarded what are called task orders to provide specific delivery services to the lunar surface. One of them could take place as early as 4th quarter of this year. That's with Astrobotic, what's called Task Order 2. We had another that we thought would take place the 4th quarter of this year, but with Intuitive Machines, but they were recently informed by their launch vehicle provider that the launch vehicle provider won't be ready till the 1st quarter of 2022. We have a relatively large delivery mission planned by Astrobotic to go to the South Pole of the Moon to deliver NASA's Viper Volatiles Investigation Rover. We have missions planned that you can see here that will go to equatorial regions as well as other missions to the South Pole of the Moon. And those are the 6 that are selected to date, and there are more being planned right now for the future. If you go to the next chart, please. So these are the locations of the agreed 6 deliveries plus 2 that are coming up soon. As I said, there's 3 to the South Pole of the Moon in the region where Artemis will have its initial landings and build up the Artemis base camp. And then there are deliveries to other parts of the moon because either there is a compelling scientific or technological reason to go visit these other areas to get data, or because for the initial delivery missions, we could get the data from those equatorial regions without having to immediately go to a South Pole landing region. There's the 6 here that are scheduled, and then there's 2 coming up. One is expected to go to Rainier Gamma area sometime probably at the end of 2023. And then another one, that would be the 7th one, and then the 8th one will go to Schrodinger Basin near the South Pole of the Moon on the far side, which will go in 2024. Now, in order to have instruments or equipment flown to the surface of the moon on these deliveries, NASA has established what's called a CLPS Manifest Selection Board from a Science Mission Directorate, Space Technology Mission Directorate, and Human Exploration and Operations Mission Directorate, who get together to look at the landing sites and look at the what the complement of instruments or equipment or technology demonstrations will be that will go on each of these delivery missions. And then the members of that board get together, they look at what things are being ready from the different mission directorates, when they are due to be ready, and they could be integrated into a delivery that a CLPS provider could take them. And then they're scheduled for either one of these missions, or they're scheduled for future ones that'll take place later than the ones that are shown here. And it's also possible beyond the 2 deliveries per year, if there's a particular need from a mission directorate to have a large delivery take place, or a dedicated delivery for a certain type of equipment that for some reason can't be sent to the surface with other equipment or other instruments. It's always possible, if funding is available, to go off in effect and buy an additional delivery mission. Go to the next chart, please. So let me talk about what type of instruments and payloads and equipment so far are going on those missions. The first set of instruments and payloads were called NASA-provided lunar payloads, and these, in effect, were scientific investigations, instruments, technology demonstrations that at the time that CLPS was being formulated were existing pieces of equipment. They were equipment that had been flown on other space flights, or equipment which was in development but did not have an assigned way to get to the lunar surface back in 2018, 2019. So these were in effect brought together from equipment that was existing, or they could be made copies of things that were existing, or equipment that was almost finished, being done by NASA field centers around the country. That was supplemented by an open competitive call called Lunar Surface Instruments and Technology Payloads, which then looked at industry, other government laboratories, and academia for both scientific instruments and technology demonstrations that were that could be assembled relatively quickly, but they weren't strictly copies of existing instruments that were already in the inventory of NASA. Since that time, there have been different tracks that have opened up to pick the future instruments, payloads, technology development, equipment. Within the Science Mission Directorate, since we use a competitive peer review model to select scientific investigations and instruments, We've moved to a model specifically for science that's called Payloads and Research Investigations for the Surface of the Moon, abbreviated PRISM. A call went out that outlined what the major science objectives were for robotic lunar investigations, as well as information that's needed to support Artemis science objectives for the first Artemis crewed South Pole landing missions. That was advertised in a solicitation called PRISM 1. Proposals were received for that. They were evaluated, and the selections will be made relatively soon for that. This first call, called PRISM 1, requested science investigations utilizing multi-instrument suites, that is, related groupings of equipment, to maximize attaining scientific objectives for the landing locations that were identified, that I talked about on the previous chart. So our goal here is to have a science solicitation like this once a year that will identify the suites of instruments that will go to 2 landing locations each year. And as I said, the PRISM 1 selection is almost complete, and there will be an announcement coming out relatively soon for what the next PRISM selection will be, including what the landing sites are projected to be. These PRISM calls will occur on a regular annual cadence. And for those that for those in the scientific community that don't propose a leading investigation providing a suite of instruments to take to the surface of the moon, but have an interest in that science area, we're now considering how to implement what's called a participating scientist call that would allow scientists to join later and participate in the data analysis and the data taking from the suites that go to the moon. No, I just spent a lot of time talking about scientific investigations and scientific instruments being developed. But as I mentioned earlier, STMD identifies what technology demonstrations, maturation, other technology developments they would like to do from a variety of mechanisms that they already exercise, like tipping points, ACOs, a number of other activities. Human exploration operations has different calls they do that develop what knowledge they want to get, perhaps to support operational planning for human exploration operations. And so the CLPS Manifest Selection Board merges all of the ideas and the selections that are coming out for these different instruments or implements, and then schedules them on the different delivery missions that'll be coming up in the future. If you go to the next chart, please. Now we foresee as there are different objectives that need to be met either for science or technology or exploration planning, or that capabilities mature among CLPS providers or potential CLPS providers, that there will be different capabilities that will be provided by CLPS in addition to simply landing a package on the surface of the moon, or maybe landing someone's rover on the surface of the moon. The ones that the different CLPS providers are investigating today to make them available for future opportunities for deliveries to the surface of the moon include surviving or operating through the lunar night, through the extended dark period, the dark and cold period, increasing further the size or the mass of equipment that can be taken to the surface, potentially providing things into particular lunar orbits in the cislunar region, providing as a service mobility, which may or may not necessarily be a rover, but there are various ways to provide mobility. You know, one could imagine devices that could move from point to point across the surface. There's a variety of different ways that could be done. Potential delivery of equipment or samples either from the lunar surface back to Earth or the lunar surface to some intermediate location. And then being able to operate and take measurements in the permanently shadowed regions of the moon for extended periods of time. If you go to the next chart, please. Now, the goals for the first Artemis crewed surface missions are called out in the Science Definition Team document that's available publicly. And that document captures the highest priority science for the first crewed mission or missions. It could, it could take more than one mission to accomplish all the objectives, and it provides the greatest feed forward to follow-on missions that would culminate in the Artemis base camp at the South Pole. And this is based on 3 elements: sample collection and return, in situ and field science, and then deployed experiments that crew members would deploy. But there's a number of things here that are very different from the Apollo era. Today there is the ability to have a lot more crew member during EVA-based measurement instruments, which could greatly expand the work that the crew could do on the surface of the moon, beyond simple field geology or sample collection, or maybe could take field geology to something of a more modern implementation on Earth than was done than simply doing the same types of things that were done during the Apollo era in the field on the moon. There are discussions over what could be done of these sub-elements robotically to prepare for when the crew is there, to make sure that the crew is spending their time on the most high-value things they can do when they're on the surface. And then also how to exploit the equipment the crew might need, such as their own rovers or tools, perhaps exploit them by telepresence when the crew is busy with other tasks, or the crew isn't at that landing site. Perhaps they're back up at Gateway in orbit around the moon. But we could continue research or data taking when they're not there. If you go to the next chart, please. One thing I want to close before questions and point out is that lunar reconnaissance orbiter operations are ongoing. It's been in orbit for more than 11 years, generated a great deal of data. It was originally, if you remember, lunar reconnaissance orbiter was started under the vision for space exploration as a reconnaissance asset and as an exploration data gathering asset out in cislunar space to support what we then thought would be human visits returning to the moon in the mid-2010s. If you go to the next chart, please. And there's a number of products today that LRO supports, both to generate plans for the Artemis crewed landings and Artemis base camp, but also for the initial CLIPS landings at various locations around the lunar surface. And these range from understanding topography of the surface, helping people who want to land on the moon develop their surface navigation techniques, look at landing hazards, look, for example, at surface and subsurface frozen volatiles. So LRO continues to operate. And one of the things that we're looking at within our exploration science planning and integration function is how we're going to continue to gather this type of data. Because at some point in the future, the instruments of LRO or LRO itself will cease to be available, although we don't think that'll be for a number of years in the future, due to the great job the LRO team has done in keeping LRO operating and minimizing its use of resources. If you go to the last chart, please. There have been a couple of changes in SMD's Exploration Science Strategy Integration Organization. I've taken over as Deputy Associate Administrator for Exploration from Dave Burns, who took over from Ben, who took over from Steve Clark. And we've added to our group over the past year of program scientist, Dr. Deborah Needham, who was formerly at Marshall Space Flight Center, and Dr. Ryan Watkins. And we continue to have Dr. Sarah Noble, who I share with the Planetary Science Division at NASA's headquarters, Science Mission Director. I think many of the other people listed on the chart you're probably familiar with. If you go to the next chart, please. So I want to thank you for taking the time to hear a short update on exploration, science, integration, LDEP, CLIPS. And I tried to leave enough time, about 10 minutes, so we had time for questions. So I'm going to turn it over for questions now.
Thank you, Dr. Kearns. Yes, we have time for some questions. If you have not already, go ahead and use the Q&A function in Zoom to put your question. The first question we're going to ask is from Dr. Amy Fagan. Could you please expand on the strategy for selecting the PRISM landing sites? In other words, what guiding documents or long-term big picture goals are there?
Thank you. What's looked at to select the landing sites is the program scientists in the Exploration Science and Integration Office review advisory committee documents that go back to the last planetary decadal survey and are then supplemented by leaked documents and other input we've received through the Planetary Advisory Committee and its subcommittees. And based on those objectives and the objectives of the Artemis Science Definition Team report, they come up with a list of candidate landing sites to address the science goals or objectives that have been identified in those documents. And I would not want to, I won't, because I haven't been in the office a long time, I won't go to any more detail than that. But if you have additional questions, we will answer them after the conference this week.
A follow-up question to that, when will ESSIO reach out to the community to select future landing sites? Is that something that talk about in the future as well, or can you answer today?
Oh, I'll have to talk about that in the future after I consult with the program scientists. What I would say is that the science community, I think, will be able to comment when we put out the community announcement for the PRISM 2 call. You'll be able to see what NASA is going to propose for the landing sites for PRISM 2. You'll be able, the community broadly will be able to provide comments to that. Anything beyond that to talk about what any future mechanism would be to provide input to those future PRISM calls, I'll have to address with the staff and respond later.
Great, thanks. So we have a question here from Mike Provenzano as well. Thank you, Joel. Will the PRISM 1A and PRISM 1B payload suite selections be made at the same time, or will PRISM 1B payloads be selected later this year?
The announcement for the 1A and 1B will be made at the same time.
Here's one from Dallas Benioff. Does NASA have a target date for another CLPS on-ramping opportunity for new providers?
NASA hasn't identified the next on-ramping opportunity yet. I anticipate there will be one in the future. It depends on both the capabilities that we hear about from the current providers, as well as things that we learn about just through public domain information from other organizations, as well as what capabilities internationals might be able to provide that the US could get access to, as well as what type of, as well as information we glean from PRISM solicitations, as well as the other mission directorates, future identified needs for either technology demonstrations or delivery of equipment to the surface of the moon, or operations demonstrations that need to be done. So we don't have a schedule yet to do another on-ramping, although I fully expect we will do that.
Okay, thank you. Here's one from Marshall Eubanks. What is the plan for an LRO follow-on? The satellite is essential but not eternal.
Yes, and that's what I was addressing at the close of the talk. We are having informal discussions within NASA about the different capabilities that might be needed as a successor to LRO, and what the various options are to go out and acquire those capabilities. And at this point, we don't have a plan for to circulate or to get comments on, but we will in the future.
Great. Here's another question. Is there payload space not used by NASA on some of these missions that could be utilized by providers, not actually the CLPS providers themselves or NASA?
Well, what NASA does for these delivery missions that are exercised through CLPS is we define a quantity, which could be a number of mass types of services we need to bring, for example, a number of instruments or technology demonstrations down to the surface of the moon at a particular location, operate for a particular number of days, and then get the data back. So it is up to the CLPS provider to put together the hardware, the software, and the mission to actually carry out what NASA is buying, but we encourage the CLPS provider, and we certainly don't discourage them from also having other customers on those same missions. Not only the same missions that NASA has issued task orders for, but we also hope that the CLPS providers will be able to get other customers for different missions that NASA doesn't even have task orders for. So those CLPS providers can go off and in effect offer that space to other paying customers of theirs. It's up to the CLPS provider to secure the launch vehicle and the launch activity to actually get them off the Earth. So the CLPS provider or that launch vehicle provider could go off and secure different customers for that launch capability. Again, what we are doing at NASA under this CLPS method is we're buying a delivery and we're getting our data back from our instruments or equipment. We take the surface of the moon and we define the set number of instruments and equipment. And anything beyond that that can be carried onto the moon or carried into space, that is the purview of the person putting the mission together, which is the CLPS provider.
Here's one from Angelica. How will CLPS interface with LETS, LETS, or maybe she means HLS for recurring services for human landers?
So I'll answer that assuming it's HLS. So the HLS is envisioned by NASA as the way to get humans down and up from the surface of the moon. And that includes some equipment and some scientific samples. I would, although we don't have any plans to do this today, one could envision that in addition to the recurring every 2 years of robotic deployments and deliveries to the lunar surface under CLPS to support scientific investigations, technology developments, exploration demonstrations, that it could be possible to use CLPS in the future to bring additional equipment down to the surface that could be useful to the crews while they're on the surface, already have them having flown down using HLS, or potentially in the future bringing equipment or mass or samples back up off the lunar surface so that you wouldn't have to try to fit everything just within one HLS mission. But that's something to think about for the future. There are no plans for that today. At least there are no delivery missions being formulated for that today. I really can't address in detail how HLS will be implemented, other than you've all read about NASA's selection for the initial capability demonstration mission. There'll be selections beyond that for sustained recurring delivery of humans, and I would think their equipment to the surface of the moon after the first demonstration mission. And much like CLPS, I would think that I would think that there could be a large number of provincial providers that could provide such a thing to NASA.
Here's one from Derek Weber. I think this will probably be our last one. How would you expect to provide communications for the Farside lander opportunity? I think he's referring to Schrodinger.
Yeah, there's a variety of different ways potentially to do that. We haven't settled on a way yet. NASA is looking at establishing a communications network in cislunar space. I know there are other nations that are also looking at that. It's also would be possible I believe, to simply purchase the data coming back as part of the CLPS provider delivery mission. So there's a large number of different options to get the data back from Farside delivery missions.
Okay. Well, thank you very much for your time, Dr. Kearns. We're going to move on. Dr. Klima, I'm going to turn it over for you to transition to the next part of the conference. Thank you.
Great.
Thank you very much.
Thank you very much. Thank you so much, Joel, and thank you for everybody from this morning. We are going to move into a networking session in GatherTown. We also have vendor booths from several of the CLIPS providers. So if you would like to go and learn a little bit more about some of the different providers in the GatherTown environment, those should be on the first floor. I haven't been in yet this morning to see. And then the posters, wait, has anybody been into, can anybody tell me if that's true? Yeah, okay. So on the top floor, we have the vendor booths, and there are areas where you can kind of mingle with one another and chat. And then at the lower level of the virtual poster area is where the posters will be tomorrow, if you want to get a preview. But I encourage you to spend your time on the first floor and talk to the folks there. And we will see everyone back at 1:45 for the focus group updates. And then we will be moving to talk to some of the executive committee members about some of their activities that dovetail with what LSIC is doing, or even help guide what LSIC is doing in some extent, and then this funding opportunities in the final panel. So thank you all very much, and have a lovely lunch if you are hungry, and networking time if you are not. Thank you all.